Hello everyone, my name is Anurag Baiju and this is our group project title Heart Disease Prediction Using Machine Learning, a Comparative Analysis Classification Models. And my team members include Balakrishna, Raju and Bhanu, Prakash, Palukuri. Objective and overview. Heart disease continues to be one of the leading causes of death globally, and early detection can save lives. But traditional diagnosis method can be time consuming and sometimes inaccurate. So our goal is to build machine learning models that can predict whether a person is likely to have heart disease based on clinical data. So we collected the data, three public data sets, cleaned and prepared the data, and implemented and evaluated three models, which is decision tree, random forest random forest, which is I worked on that, and logistic regression. And our methodology, our workflow followed four main stages. Data collection, we gathered three data sets which with different formats and column names. This was and pre-processing. This was crucial to align all of the data sets, handle missing values, and standardize data types. 3. Model training. We trained the models separately. 4. Evaluation. Finally, we compared them using metrics like accuracy, recall, latency, throughput, etc. And we can go through the Google Colab where we worked on our project, and we imported libraries such as pandas, which is for data manipulation, matplotlib, seaborn for visualization, and time for latency measurements. And in this section we cleaned and merged the data, and this was the no normalize the column names, and we replaced this with this. So this was the process where we cleaned and took all of the data and saved into this. As we can see, this is the final output where we got the clean data, which has 1120. And this was the part where we concatenated the data. After aligning schema, we managed the data set using pd concat and drop duplicates and irrelevant rows. Then we handle categories such as sex, chest pain, and slop, etc., etc. And we saved into this. And this one of the model that my teammate worked on, decision tree classifier, as we can see all this. And this is the model that I worked on, which is random forest classifier. I imported these libraries as I mentioned earlier, and just I imported the data set and scaled the features, trained and split it, and yeah, initialize the trained model, measure the latency for prediction, and calculated the metrics and display the. And this code I used for heat map, as we can see, and this is the result that I got. Classified result: accuracy 85.71, latency 547 seconds. No, 0.0547 seconds. Throughput is 4093 prediction per second. And as you can see, the confusion metrics, and this is all the data we got. 0 means no, yes means 1, and this is the data. And yeah, support, recall, and everything. This is another model that we worked on. This is the accuracy comparison model of each of the model that we worked on, which is decision tree, random forest, and logistic. As we can see, the random forest is much higher compared to the other ones. It has 86%, which makes it a viable option for handling data sets like this. And latency is high on random forest, which means it should be taking a lot of time compared to the other one. The other one is better for latency, and if you're looking for just a latency purpose, I don't think random forest is the best option. And throughput comparison. Throughput comparison is the throughput we get per second. As we can see, the throughput on decision tree and logistic regression is much higher compared to the random forest. Okay, so that's a comparison between all three models, and we can see the correlation heat map of all the rows. And yeah, cholesterol level, distribution by heart disease, and heart disease count by chest pain type. And that's it. That's the live demonstration. And my contribution to the project is random forest method. As we saw, random forest is ensemble of models that many decision tree and that builds many decision trees and averages result. It's robust, performs well even in noisy data, like we saw earlier. The data that I worked on is kind of noisy. It's not like pre-processed good data. And the implementation using these kind of libraries, key parameters, and everything. And random forest results and analysis. Accuracy. The model achieved an overall accuracy of 86%, the highest compared to other three models. And clinical performance. Most importantly, it achieved a recall of 90% of the disease class. It means successfully identify 90% of the patients who actually had heart disease. It correctly classified 114 out of 126 sick patients, only missing out 12 cases, which is really good. And comparative analysis. Compared to decision tree and logistic regression, random forest was the most accurate and clinically reliable. But the trade-off for the uh, clinically reliability is the latency and throughput. The latency is very high, as we saw, and the throughput is not that much. As for the conclusion, my findings: random forest is the most effective model for this specific task. It is high accuracy. Recall makes it more suitable for healthcare. In the we can't make any mistakes. It's gonna be vital if you made any mistakes. Whether missing, where missing a diagnosis can be life-threatening, despite being slightly slower and most clinically valuable data. But it is the most clinically valuable model in our analysis. And that's all the conclusion there is. Thank you very much for listening to my presentation. Have a good day.